right, so we're going back to number 9. The reason I skipped 9, 10, and 12 have like one little extra step to them. As a heads up, the number that will go in the little box will be a fraction. I know. But remember, if you're not allowed a calculator, I have to keep the numbers nice for you. So they will still turn out nice. Okay. And then there is just one extra little step at the end where, because it was a fraction, you end up like reducing the fraction, like reducing the numbers that are left over. But I'll just show you how it works. It's the same process. All right. Look at your divisor. What would make that 0? Like if you set that equal to 0, what would you get? 1/2 is what goes in the little box. Okay. Panicking is not allowed. Now check your countdown. Is your countdown in order or do we need any zeros? It's good. Okay, so it'll be 2, -5, 4. What's this one?
1, -1.
-1, 2, 7. Draw a line. I promise it's going to be okay. I know you're all like worried. I promise it's going to be fine. Bring down the first number. Multiply, add, multiply, add, multiply, add. You ready? 1/2 of 2. Good. Add the column.
-4.
1/2 of -4. -2. Add the column 2. Told you it was going to be all right. 1/2 of 2 is 1. Add the column. That's kind of interesting. 1/2 of nothing is nothing. 0 is a pleasant number in that way. Add the column 2. 1/2 of 2 is 1. Add the column 8. Now, you just get one extra step when it was a fraction like that. But listen, it doesn't affect the remainder. The remainder is going to stay 8. That's not going to change. Do you see how all these numbers, you can do 1/2 of them? So you just have to do that. Okay. I usually just write it right below, but not the remainder. That's just like the leftover part. All right. So we're actually going to get 1, -2, 1, 0, 1. Do you see how I just did 1/2 of all those numbers? Or I divided them by 2, in other words?
Yeah.
Now we're going to put our x's back in. It's like the final answer. We're going to start with 1x to the what? Good. Now, if you're racing ahead of me, that's cool, but hold on because there's a 0 in this one. It would be -2x to the 3rd plus 1x squared and plus 0 x's. So you can write plus 0x, but I'd kind of be happier if you just don't put any x's, like just skip that. Plus 1 and then plus 8 over 2x minus 1. Let's just try that again. Look at your divisor. What would make this 0? -1/3. Ooh, that one's a fraction and negative. Okay, is our countdown in order or are we missing some things? Bless you. Bless you. We're missing just plain x. Do you see that? It goes straight from squared to x to the nothing. So we are going to need a 0 in there. Okay. So it'll be 3, -5, 7, 0, -1. And I promise it'll turn out okay. I really do. Bring down the first number. Stick with me here. -1/3 of 3. -1/3 times 3 is -1. Good. Add the column. -6. -1/3 times -6. Okay, first of all, the negatives will cancel. 1/3 times 6 is 2. Very good. Add the column. All right. -1/3 times 9 is -3. Good. Add the column, you get -3. And then negative a third times negative 3. Negatives cancel. So 1. And this is kind of cool. What's our remainder? What that means is it divided out perfectly. And we're going to have a bigger conversation than that about that like in future because anyway, it works. What do all of these divide by? 3. Divide them all by 3. You get 1, negative 2, 3, negative 1. Good. And then you don't ever touch the remainder anyway, but in this case it was 0, so it really doesn't matter. And then when you put your x's back in, you're going to start with x to the what? Third. So it's 1x to the third minus 2x to the second plus 3x minus 1. No remainder. That seemed like that was going okay. Oh, wait. Yes, ma'am. Go ahead.
So is it only with the halves that you take like x or whatever?
Like reducing these at the end?
Yeah. Where one is it only with the one half?
No, we did that with the other ones too. Like, see how this started to the 4th and our answers to the 3rd? It's always going to be 1 less than what you started with. Go ahead. Yeah, basically. But I like to think of it more like reducing a fraction. For example, hey guys, these are good questions that I'm answering, so you want to listen to the answers. For example, if you had something like 5/15, what does that reduce to? Like, I'm more thinking, you can think of it as GCF if you want, but this is kind of how my brain thinks of it. What you're doing is reducing a fraction. Okay, like at the end there. Maybe we will try that last one. What's going to make your divisor 0? Good, negative a half. You guys have answered like every question that there is, so you're doing perfect. All right, check your countdown. Is it in order or are we missing anything?
Yep, that's good.
That is good. All right. So 4, 4, 1, negative 6, 2. And again, usually we get to a point where everyone's kind of like working ahead of me, and that's totally fine. But just check that your answer's right. Negative a half times 4, negative 2. Good. Add the column, you get 2. Negative a half times 2 would be negative 1. Add the column, you get 0. So this is kind of interesting. Negative a half times 0, 0. Add, you get negative 6. Negative a half times negative 6. Negatives cancel. So half of 6 is 3. Add the column, you get 5. Now, when you reduce, or you can think of it like GCF, you don't touch the remainder. That's just going to stay. That's like leftovers. All right. But what do the rest of these divide by? 2. So you would get 2, 1, 0, negative 3. And you start with 1 less than you had in the first place. So we're going to start with x to the third. So 2x to the third plus 1x squared. And then you can write plus 0x if you want, but I'll kind of be happier if you just skip it. Minus 3. And then plus what? Perfect. 5 over 2x plus 1. All right, that's going well. I'm going to just do like a couple of these long division ones. We'll practice more with it next time. Just as a heads up, next class, we will not cover any new material. We will practice division. That's what like we will do. Okay. But I'm going to review it just with plain numbers before I start putting X's in there. I'll get that in a minute. Does 3 go into 1? We're going to do like review of 4th grade or whenever this is. 3 does not go into 1. Does 3 go into 16? Not perfectly, but it will. 3 times what will get you as close to 16 as possible? 5. Okay, so 5 goes here. 3 times 5 is 15. And now this is more about organization than anything else. Do you see how I lined them up? We're going to subtract. What is 16 minus 15? 1. Good. Do you remember what you do next? You drop down the 3. A lot of people like to draw an arrow. Oops, Sorry, I moved it up because I'm standing in the way here. And then you do it all over again. It's cyclic, all right? So 3 goes into 13. How many times? They're like, how can you get as close? 3 times 4, so 4 is going to go up here. 3 times 4 is 12. We're going to subtract. 13 minus 12 is 1, and then what? Drop the 4 down. Do it all over again. It's a cycle. How can we get as close to 14 as possible? Good. 3 times 4 is 12. Do you remember this from like a million years ago? Hold on. 14 minus 12, 2. Bring down the 5. Last time, 3 times what will get you like pretty close to 25? 3 times 8 is 24. When you subtract, you get 1. That's your remainder. In elementary school, you just did that. You put an R with the remainder 1. Do you remember that? I heard some yeses and some nos, so we'll see what happens. Now, I'm going to skip these two. If you look back, these 2 problems are on the page we just did. I was going to do them by synthetic division and long division and show you it comes out the same either way. But I'm going to skip down to these 2 because what I usually get asked is, I like synthetic division better. Usually most people do. I always get like 1 or 2 people that like this better. And I'm like, oh, that's interesting. I mean, cool. But there are times you need long division. For example, girls, if you're dividing by this, you can't do synthetic division because what number would go in the little box? You can't do it because of the squares. So that's why you have to do long division. That's why it's a necessary thing. You're going to have to watch and pay attention and stay organized and line everything up, okay? You compare the first 2 terms. I need to turn an x squared into a 2x to the 4th. What would I multiply by to turn this into this? 2x squared. Very good. Now listen, you're going to take the 2x squared and distribute it through here. Do not draw these rainbows on your paper. I'm going to have to erase them because it's going to get too cluttered, okay? But that's what you're doing, is you're going to distribute it through. And when you write it right under here, your columns will line up, okay? So when you distribute, what do you get? 2x to the 4th plus cubed minus, good. Now think back to the one with just plain numbers that I did. Once we got there, we subtracted. So you have to put parentheses around the whole thing, and we're going to subtract. This is the step that gets people because negatives are hard. Okay, so we're going to subtract. 2x to the 4th minus 2x to the 4th cancels. Hey, Miss Cole, will that happen every single time? If you've done it correctly, yeah. You want that first term to go away. So let's do the next one. It's -5 minus 4. You're subtracting. -9x to the 3rd. Now this is 2 minus -2. You are subtracting 2 minus -2. What happens when you do minus a negative? Plus, so 2 plus 2, 4x squared. You're going to bring down the 3x and then do it all over again. So let me erase these little rainbows. Okay, now look, it's not, if you're distributing already, you're a step ahead of me. I need to turn an x squared into a -9x to the 3rd. What would I put up here? Good, -9x. You're going to distribute that -9x through there. Don't draw those little rainbows. I'm going to have to erase them because it gets too cluttered. But distribute a -9x. It'll all line up perfectly. It's -9x to the 3rd. And then what? -18x squared. Your cubes should line up and your squared should line up and your x's should line up. Like it'll all line up. And then negative 9x times negative 1 is plus 9x. And you need to subtract the whole thing. This is the step that gets people because negatives are hard. Okay? But what happens to the first column? Yeah, that's going to go away. It will, like, unless you had a whoopsie. Now this is 4 minus negative 18. So plus 18. So 4 plus 18, 22 x squared. And then this is 3 minus 9, negative 6x. You're going to bring down the negative 4 and then one more time. And you're like, where does it end? One more. You need to turn an x squared into a 22x squared. Plus 22. Let me erase these little rainbows. You're going to distribute a 22 through here. So what would that give us? 22x squared plus 44x minus 22. Now the first column will go away. Whatever you end up with is the remainder because we're done. There's no more numbers to bring down. Yes, 22 times 2 would give you 44. So we're subtracting. Again, that's the step that gets everybody because negatives are hard. All right, negative 6 minus 44, negative 50x. And then this is negative 4 plus 22, 18. And this is why you're probably before like, why does she always put plus? This entire thing is your remainder, the whole thing. So put plus, and you're not going to do any more work. It's just going to look weird. All right. It's going to be negative 50x plus 18 over. And what did we put it over? You just tack it on at the end. Like the divisor, the x squared plus 2x minus 1. It looks awful, but we didn't have to do any work. You just write that thing over that thing. It's just the remainder over the divisor.